Good morning, dear students. My name is Ferhan Mazher, and today the subject we are studying is Cambridge O Levels Physics 5054. Today we are working on the solution of the past papers, and today we have set our hearts to solve a paper about alternative to practical. We call it paper 4. We have selected October and November 2011 4-2 paper. This paper 4 or this ATP paper belongs from the zone 2, or you can say the variant 2. So let's start today's paper. The time allowed for this paper is 1 hour, and the marks for this paper, there are 30 marks. So on your screen, you can see this is showing up, and here we go. October, November 2011, 4-2 paper. So let's start today's paper. The first question coming up on your screen. A student measures the focal length of a converging lens. The student sets up the apparatus as shown in the figure 1.1. So here you can see this is a meter rule, and with this meter rule, this is the stand. On this stand, we have a converging lens. Here we have a screen. Here we have an illuminated object. The distance D, the capital D, between the illuminated object and the screen is fixed initially at 1 meter. So they say the distance between the object and the screen, the distance between the object and the screen is 1 meter, and it remains fixed. The image on the screen is blurred. Describe the adjustment that the student makes to obtain a sharply focused image without changing D. So if you do not want to change the D, it means that the distance between the object and the screen, that cannot be changed. The value of the D, capital D, cannot be changed. The only option then you will have is to move the converging lens forward and backward along the meter rule, and find a position on the meter rule when the image on the screen is sharp and clear. Another method can be that you might use a converging lens of a different focal length. So let's see, I have written this answer. So my answer is also coming up on your screen. So this is my answer. Move the lens forward and backward until you get a sharp image on the screen. So that was a 1 mark question. So here we have the marking scheme of this paper. So the marking scheme is also showing up, question 1A part. So you can see I have already checked my answer with the marking scheme. Okay, so the next question is, the focused image is at the top of the screen. Describe an adjustment that the student makes to move the focused image to the center of the screen. Okay, so this can be, there can be 2 or 3 methods for doing this. One method is that move the object little, the image is at the top of the screen. So if the image is at the top, so it means that you should change the height of the object. So when you will change the height of the object, the location of the image on the screen, that will change. Another good method is that you can align the center of the object, the lens, and the screen with each other. Automatically, the image will be in the center. So these are my suggestions. Okay, center of the object, lens, and screen should be aligned. That's a single line answer. So the marking scheme of the question of 1, second part is also showing up on your screen. One method is to raise the object, lower the lens, allow, raise the screen. Okay, so these are some methods. This is the marking scheme. Then the third part, the lens is in a holder on a stand. The position of the center of the lens is to be marked accurately on the stand. Describe how the student does this. So what you can do, measure the length of the edge of the stand, which is along that meter rule, and then divide that length with the 2. So then measure this the half length from one side of that stand and mark its position in the center. Automatically it will be the center of the stand. So method is that measure the length of the stand, the edge of the stand which is along the meter rule, and divide it with the 2, and then mark the midpoint of that side with a marker on the stand. So this is the idea. My answer is that measure the length of the lens stand touching meter rule, divided with the 2, mark the middle of the length with the help of the scale. So by using a scale, mark the middle point of that edge of the stand on that edge which is along the meter rule. So let me show you the marking. He says any sensible answer for finding the middle of the side of the block. For example, how non-parallax views such as viewed from above, and measure of the length of the block and divided by the 2. So this is the part which we have. This is the way we have answered. Okay. So that was the question number 1. So it's A part. Now we are going to next question. It's B part, I mean. The student finds that for the same value of D, there are 2 positions of the lens that produce a focused image on the screen. These positions are at the distance U1 and U2 from the illuminated object as shown in the figure 1.2. The 2 distances U1 and U2 are measured for D equals to 100 meter. The values obtained are U1 equals to 0.42 meter and the U2 is 0.56 meter. The question is calculate the distance between the D between the 2 lens positions. Okay, so the D will be U2 minus U1. Very simple, straightforward. So we have the value of the U2 and we have the value of the U1. Just subtract them from each other. You will get the distance between the 2 positions of the lens. So very simple. Okay, so let me show you my answer. Okay, here we go. So the D will be equals to U2 minus U1. That will be 0.56 meter minus 0.42 meter. And that will be 0.14 meter. So that is my B first part. And let's check. 0.14 meter is the right answer. Okay. So now we are going to the next part. He says, this is the next part. He says that theory shows that the focal length f of the lens is given by the relationship f is equals to, in the numerator we have d square minus capital D square minus small d square divided by the 4 into the capital D. Calculate the f. Okay, so we have the value of the d, that's 1 meter. We have the difference of the positions of the lens. Small d is 0.14 meter, and so divided by 4d. Simply we will put the values and we can calculate the focal length. Okay, so let me show you. So here we go. So f is equals to d square minus d square divided by 4d. So that will be 1 square minus 0.14 square, and the whole thing divided by 4 into 1. When you will enter these values in your calculator, your answer will be 0.2451 meter. So the focal length is 0.2451 meter. So let's check. 0.451 meter. Okay, so that is the answer. Okay, so now we are going to the next question. And he says, in the question, he says, the student repeats the experiment for different values of d and calculate the values of the d square minus d square each time. So figure 1.3 shows the student's results. So you can see the d value, the distance between the object and the screen is 1.1, then 1.2, then 1.3, then 1.4, then 1.5. And then they have calculated the d square minus d square. And they have found these values as 1.08, 1.18, 1.29, 1.38, 1.47. So then their question is, so we have d, and this is d square minus d square. So their question is that On the figure 1.4, plot the graph of d square minus d square in meter square on the y-axis against the d meter on the x-axis. Start your graph from d square minus d square equals to 0.90 meter square and the d equals to 1 meter. Draw the straight line of the best fit. Okay. So you can see this graph is given to us, and in this graph, this is figure 1.4. On the y-axis starting from 0.9 and the x-axis starting from 1.0. So this will go up to 1.5 and this will go up to 1.47. So I will plot these points on the grid and then I will try to draw the line of the best fit. So let me show you the whole thing together. So this is that question which they want us to answer. We have to plot this graph. Okay. So let me show you the solution. So here we have, you can see that we have labeled the x-axis. On the x-axis, we have represented the capital D. The unit is meters. So it started from 1.0, then you have 1.1, 1.2, 1.3, 1.4, 1.5, and 1.6. On the y-axis, we have represented the capital D square minus small d square, and it is in meter square. So I have represented that, and that will be that is starting from 0.9, so it goes up to 1.0, 1.1, 1.2, 1.3, 1.4, 1.5. So then I will plot those points. The points are given to me. The points are here. You can see. So the points are here. So 1.1, at 1.1, we will have 1.08 at 1.1. At 1.1, we will have 1.08. So this point, okay. At 1.2, you will have 1.18. At 1.2, you will have 1.18. Okay. Then at 1.3, you will have 1.29. At 1.3, you will have 1.29. This is the dot. Okay. So then at 1.4, you will have 1.38. At 1.4, you will have 1.38. And at 1.5, you have 1.47. At 1.5, it is 1.4 and 7. Then I will draw a line of the best fit, and you can see I have tried to draw the line of the best fit. And this point is left, only one point is left on below the line, and one point is above the line. So this is the line of the best fit. So this is the line of the best fit. So after drawing this, what is the question? Okay, we have drawn this. He said, determine the gradient of the line of the best fit, show you're working clearly. Okay. So if you want to find out the gradient of this line, suppose I will take this point and this point, I will make a triangle here. So the gradient of this line will be the rise divided by the run. So let me show you, I have done this. So because we want to find out the gradient, so I have taken 2 points. One point is 1.4, 1.38. Another point is 1.1, 1.08. So y2 minus y1 divided by x2 minus x1. That's the formula for finding the gradient. So we will have y2 minus y1. That will be 1.08 minus 1.38. And in the denominator, we will have x2 minus x1. That will be 1.1 minus 1.4. So 1.08 minus 1.38 will be minus 0.3, and 1.1 minus 1.4, that will be minus 0.3. So minus 0.3 divided by minus 0.3, and that will be 1. So the gradient is approximately 1. So let's check. So you can see it's up from 0.97 to 1. Okay, so our answer is right. Then the question is, Calculate F using the relationship F is equals to gradient divided by the 4. So whatever is the gradient here, you divide it with the 4. So the gradient here is 1 divided by 4, 1 divided by 4, and that will be 0.25. 0.25 is the right answer. He says, calculate the focal length you have calculated, then the D part is, explain why it is better to determine F using the method in the C rather than the method in the B. You see, in the method B, there was only one reading which you have taken. And in the methods, in the C part, the method we use, we have taken 5 values, 5 different values of the D. Okay. So we have taken 5 different values of the D, and from there, we have found the average value of the focal length. So the in method C, 5 readings have been taken. Thus, average value of F is found. This makes it more accurate because you have taken 5 readings and then from them, you have calculated the focal length for each reading. But in the B part, that happened in the C part. In the B part, you have taken only 1 reading. So in the C part, we have taken different readings and we have taken the average. So when you take the average, then it makes it more accurate. So in the method C, 5 readings have been taken, thus average value of F is found. This makes it more accurate. This is the answer D part. Question number 1 is D part. So we are done with this. Okay, so now we are going to the next question. The next question is question number 2. He says, a teacher demonstrates the force on a wire carrying a current in the magnetic field. Figure 2.1 shows some of the apparatus used. So we have here 2 magnets. This magnet is north, is facing the south of this lower magnet. So we have a wire between these 2 and the current is flowing through that wire. So their question is the current is to be varied and measured. On the figure 2.1, draw the circuit diagram of circuit used to provide the current and include a method to vary and measure the current. So you connect this with the battery, you connect it with the switch, you connect it with the variable resistor. You see the variable resistor in the start of the experiment, keep the, the resistance maximum and then gradually decrease the resistance of the variable resistor. So this will help you to increase the current in the circuit. Okay. So this is that diagram. The first diagram which they asked is to. So here we have North Pole, South Pole, and this is the wire. And you can see with the wire we have connected an ammeter, a variable resistor, and a battery. Okay. Okay. Question number 2, second part. So the question is the current is to be varied and measured on the figure 2.1. Draw the circuit diagram. Circuit used to provide the current. Include a method to vary and measure the current. Okay. Describe how to increase the current in the live wire. So how you can increase, there can be many methods. You have connected there a variable resistor. So in the first experiment, in the start of the experiment, you keep the resistance of the variable resistor maximum, and then you gradually decrease the, when you gradually decrease the resistance of the variable resistor, uh, when you decrease its value, the current flowing through the circuit, that increases. Okay, so that's my answer. So question number 2A and its second part. Okay. So start experiment with maximum resistance of the variable resistor. Gradually decrease the resistance of the variable resistance. This will increase current in the circuit. So very simple and a straightforward question. So he says decrease the variable resistor resistance. Okay, the next question is describe how to reverse the direction of the current in the wire. So connection of the wires with the battery, just switch them, interchange them with each other. So the direction of the current flowing through the circuit, that will change. Reverse the connection to battery, direction of the current in the circuit will reverse. So this is that answer. Then their question is describe how to reverse the direction of the magnetic field. You can change the direction of the magnetic field by changing the polarity of the magnets of the top magnet and also for the lower magnet. My answer is change the polarity of both top and the bottom magnets. Hmm. So the marking scheme is showing up on your screen. He says reverse the connection to the battery. Okay. Now the question is the current is increased to a very large value. So just one problem this may cause. You see, when the current flows through the wire and the heat is produced, the thermal energy is produced. Okay. So when you increase the current, that energy produced, the heat produced becomes larger. So when the heat becomes larger, the resistance of that object also changes. It will probably increase. He says the too large amount of the current can heat up. Too large amount of the current can heat up the wire. Wire might melt. Hmm. This is that last part. A teacher demonstrates convection in water to a glass. The teacher fills a large beaker with cold water, as shown in the figure 3.1, 3.1a, and leaves it to stand for 10 minutes. He then places a purple crystal at the bottom of the beaker. The crystal starts to dissolve and the water around the crystal turns purple. Gentle heating is applied to the beaker directly underneath the crystal. as shown in the figure 1 point, as shown in the figure 3.1b. Okay, so we have put up crystal here, and from here, from the bottom, you are heating it up. So that's the reason why the teacher uses a large beaker. You see, when you will use a large beaker, lot of students will be there in the lab, so they will be they will be able to see uh, what is happening inside the beaker. So it's that's why they use a large beaker. Another thing is that if the beaker is large, then the purple color will take some time to spread in the beaker. So when it will take time, so you will have the time to observe it. Okay. So we are on the question number 3, A part. In larger beaker, color will take longer time to spread in the water. So you will have the time to observe that how this spreads. Okay, so that is the A part. Okay, so this is question number 3, A part. Then the question is, explain why the teacher leaves the beaker of water to stand for 10 minutes before placing the crystal at the bottom. Okay, so when you started your experiment and you fill the water into that beaker, and then before you put the crystal, the purple crystal in the water, you wait for 10 minutes. Why you wait? You let the water become totally calm and steady. Okay, allow time so that the water becomes steady. Water stops moving. The marking scheme says the water stops moving. Okay. So then he says, explain why the water is heated gently. We will heat it gently so that the watercolor spreads slowly. Speed of the color can be the spread of the color can be observed by students. So you do it gently and slowly so that the students can observe the spread of that color. Okay. On the figure 3.1b, draw the initial movement of the water as it is heated gently. You see, you are hitting it from the bottom and you are hitting it gently. So here is that crystal. So very simple. I have made that diagram also. Okay. So from here you will heat it, and this is the purple crystal. So the convection currents will be produced. The convection currents, they will set in. So where the crystal is and underneath it, you are providing heat. So the water will rise upward. The water will, when it will absorb the heat, its density will become less. This water will goes up. It will go up, and the dense and the water will come down. So this will set up convection currents. So you can see I have shown here convection. I have shown here the convection curves, as you can see. This color is spreading. Okay, so this is question number. B part. Question number 3, B part, the marking scheme is showing up. Okay, so then he says, one question explain why the water is gently. We heat it gently so that the why we heat it gently. so that the color spreads slowly, spreads slowly. Spread of the color can be observed by students. That is the reason to heat it gently. Okay, you're done with this. Now the question is the teacher speeds the demonstration 5 minutes later. So that's why it is better to use another beaker of water than to reuse the same beaker and the water. You see, after 5 minutes, the water will be still warm and the water will have already color in it. And some color will be also on the beaker. So it's better to use new beaker and the new water because that water has already been colored. So question number 3 is the water and the beaker are warm and the water is colored. That is the reason we will not use that water which was used in the previous experiment. We will not use that water. We always use the new water, the fresh water, the new beaker. Okay. So this is the answer. Okay. So we are going to the next question. The next question is question number 4. A teacher demonstrates the existence of a background radiation in the figure 4.1 shows a counter and a radiation detector placed on a bench with no laboratory source of the radiation present. State the name of the suitable detector. You see, we are using, for example, this is called the GM tube, okay? Geiger-Müller tube, we also call it the GM tube, and we are using that to, okay? Hmm. So the answer of question number 4A part is showing up on your screen. Then the question is, the teacher measures the count for 2 minutes and repeats this 5 times. He counts, the counts recorded each time are 58, 46, 69, 53, 42. Calculate the average count per second. Give your answer to the significant figures. Okay. So GM tube, the Geiger-Müller tube, and now the B first part, they want me to find out the average. So how you find the average? You simply add the data and you will divide with the number of data. So it will be 58 plus 46 plus 69 plus 53 plus 42 equals to, that will be 268 divided by the total number of data. So that will be 5. So 268 divided by 5 will be 53.6. 53.6 is the right answer, sir. Then the question is state why the 5 counts are all different because you see the radioactive decay. The radiation is given out because the radioactive decay is happening. So when the radioactive decay happens, the you cannot, I mean, it's a random process. The radioactive decay is a random process. That's why every time you take the reading is little different from each other because the radioactive decay is a random process. So radiation is a random process. That's why the readings are different from each other. So question number 4B, second part, the answer is also showing up on your screen. Radioactive decay is random in time. Okay. So random means you cannot predict that when will happen, when a nucleus will break, when the radioactive decay will happen. Plus, you cannot tell that which atom will decay. Okay, the next question is explain why safety precautions for the radiation hazards are not necessary while taking these readings because you see the GM tube is being used to find the background radiation in that area. So the background radiation is the radiation which is due to, not due to a source near you. It is all the time. It's a radiation which is all the time present around us. So its sources can be different, but it's the radiation which is all the time present around us. And our body is used to this radiation. So this radiation normally do not cause any harm to our bodies. So there is no need for any precaution because there is no source of the radioactive uh, radiation. He says radiation is a random process. The question for C part is no radiation source is present, only background radiation is present, and the background radiation is always present around us. And our bodies, they are used to it. So it will cause no harm. So let's check from the marking scheme. No radiation source, count rate low, always present. Environment, no additional hazard. Some source is in the lead source. So there is no source, okay? So we are done with the question number 4. So my dear students, today we have done question number, I think, all the questions of the ATP paper. This paper 4 was from October, November 2011. The number of the paper is 42. The subject is Physics 5054. And this solution is by the Ferhan Mazher, and my name is Ferhan Mazher. So if you find this video interesting and useful, please like this video. Also share the link of this video onto your own Facebook and Instagram and Twitter, because if you do this, this will help me promote my channel. So I think it's a great blessing for me that I can make these videos. I'm trying my best to make maximum videos, and the time the life allows me, I put into the YouTube. So it's a blessing for me that I can make this and I can touch so many people around the world, especially my students in Pakistan, especially in the city of Karachi and in the city of Lahore, in the city of Sargodha, Faisalabad, Multan, and my students in Bangladesh and in Mauritius, in Brunei, in Saudi Arabia, in UAE, in Sri Lanka, in India. So all these students, I want to say thank you very much, everyone, for watching my video and learning from these videos. It's a blessing for me. Thank you very much, sir. Have a good day. God bless you all.